Imagine you're a software engineer trying to squeeze every last drop of performance out of your code. You've optimized, you've profiled, you've tuned, but you still need that extra edge. That's where a little-known trick in compiler optimization comes in. I discovered this hidden gem while digging through the depths of GCC's documentation. It's called aliasing optimization. Aliasing is the ability of a compiler to hoist constant values out of loops and cache their results. In other words, instead of recalculating the same constant value over and over again, it can memorize it once and reuse it. Sounds simple, but trust me, it can have a huge impact on performance. But here's the catch: it only works if the compiler can prove that the constant value is, in fact, constant. And that's where it gets tricky. The compiler needs to analyze the code and figure out if the value is being modified anywhere. I learned that this is where constant folding comes in. Constant folding is a powerful optimization technique that allows the compiler to evaluate constant expressions at compile time, rather than runtime. It's like the compiler is saying, hey, I can see that this value is always going to be 5, so I'll just replace it with 5 right now. And that's exactly what I tested in my experiments. But what about when we're dealing with complex expressions that involve multiple variables? That's where the compiler's alias analysis comes in. It's like a superpower that lets the compiler see through the code and understand how all the variables are related. And I found that alias analysis is not just for complex expressions, it's also essential for modern CPU architectures. You see, modern CPUs have this thing called a register file. It's a small, fast memory that stores the values of all the registers. And if the compiler can't prove that a variable is not aliased, it can't safely store its value in the register file, which means it has to use a slower memory instead. A true performance killer. So how can you, as a software engineer, take advantage of this optimization? Well, first, you need to understand how your compiler works. What optimizations does it perform? What's its alias analysis strategy? I learned that GCC's O2 flag enables aliasing optimization, but the default flag is more conservative, so you might need to tweak it depending on your specific use case. Next, you need to rewrite your code to take advantage of this optimization. That might involve breaking up complex expressions or reordering your code to make it more readable. And don't be afraid to experiment and test different variations to see what works best for your specific problem. Finally, you need to keep an eye on your compiler's output and make sure it's performing correctly. You can do this using a variety of tools, from GCC's built-in profiling to external libraries like Valgrind. And remember, this optimization is not just a one-time job, it's an ongoing process that requires continuous monitoring and tuning. In conclusion, aliasing optimization is a powerful tool in a software engineer's toolbox, and it's essential to understand how it works in order to squeeze every last drop of performance out of your code. So next time you're optimizing your code, remember this hidden gem and see if you can take advantage of it. Don't forget to like and subscribe for more tech tips.